Welcome to today's webinar. The topic today is perfect switch from Rfem 5 to Rfem 6. Today we present the first part of the webinar. I will be the presenter today. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the technical content of the website, German and English webinars, newsletters, and so on. My two colleagues, Andreas Niemeyer and Florian Hittemann, will support me today. They will answer your questions during the webinar. Andreas Niemeyer is the main responsible person for the development of Rfem 6. And Florian Hittemann is also responsible for Rfem 6 and also for the add-on or the optimization add-on, etc. Okay, I show you how you can ask questions. At first, I switch off my camera that you can see the full screen. You can click on that link with the question mark, then enter your question here, press send, and my two colleagues will receive your question and they will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, at first I say something about the content. I explain differences and similarities between Rfem 5 and Rfem 6. Explain also advantages of the new design concept. Show you new features in Rfem 6. And the single points are mixed up in the webinar. I start with a new model. That's the finished model. A simple model with steel frames and a concrete surface. And I explain you step by step what is similar, what is new, and so on. It's also valid for, the webinar is also valid for RSTAB, but in RSTAB there are no surfaces possible, but the other workflow is also valid for this program. Okay, we start in Rfem 6, and with this login window you can see the first big difference between Rfem 5 and RSTAB 6. We have now a modern online license system. You don't need any hard lock or network server. The new online licensing system allows licenses of Rfem 6, RSTAB 9, Rwind, etc. to be easily distributed and assigned to respective users via the Dlubal account. It's very flexible and easy to use and to share the licenses. I log me in on the other screen that you can see my password. Just a moment. Okay, so now I'm logged in. So I go right above to the license manager and some additional hints. You can see all your add-ons that you bought, and you can borrow the license up to 30 days. And you can return the license earlier. And when you borrow the license, it's blocked for you. You can work offline without any internet connection, etc. As I said, it's very easy to use and also to handle. So I'd start with a new model right above, new model. So, and we start with the first dialog. It's a similar dialog as in Rfem 5, but the user interface is very modern. So I start with a model name. I call it extension. So yeah, and yeah, a new feature, a small feature, you can select a type of model, for example 2D, XY, 3D. You can this allows you to put on the model three-dimensional loads, and the results can be 3D internal forces. Also for the 1D, that's this selection here. Okay, so then we turn to the next dialog, the add-ons. That's the next difference to Rfem 5. The add-ons are now directly integrated into the main programs. This allows to the individual parts of the program to be interact with each other. Example, for example, building model. You can determine the floor masses for the dynamic analysis. So what's also an example, you can do a 3D calculation with the building model and then design, for example, a concrete slab as 2D model, or timber slab, etc. Or another example is you can determining the ideal tightening moment of wooden beams using the add-on torsional warping, and for the timber design. So what's another example? You can consider the staggered form finding process using the add-on construction stage analysis. So this one. Where are different or various examples for this new feature, and that's a quite important advantage against Rfem 5. So we select the concrete design and the steel design. So, and turn to the next dialog. And I have to mention, you can activate or deactivate the add-ons anytime. So then the standards, as also in Rfem 5, you have a lot of international standards. We use the Eurocode and in our case the German National Annex for our example. So we would like to use the combination wizard and also the load wizards. We selected that here above. So then settings and options. That's also a quite new feature, the member representatives and the member set representatives. And for members and member sets with the same properties, you can use representatives for model organization, design, and documentation. We will use that feature in our simple example for today, and you will see that's very easily to handle, and it's also a big advantage. So then that's the properties of the member representatives. You can change it. We will leave the settings, but that's also important to mention the model parameters. You can import of the construction site for load determination. So we select a place or a location. We enter the location Leipzig, it's a subsidiary for our company. So you can see the snow load zone, the wind zone and yeah, the parameters and values. So, and we can also see the seismic map, but we don't do any seismic design today. So we leave the dialog, and now the program imports all the values, and we can use the values later for the load wizards, for the snow load and for the wind load. So you can see that's Leipzig, the altitude, and so on. Okay, now we can leave the dialog. So that's now an empty window. And as I mentioned, with that button left above, edit model base data, you can return to the dialog anytime and select any add-on. So then the next difference, or what is new in Rfem 6, that's the Dlubal Center left above. I click on it. Yeah, you can see your folders. That's quite similar to the project manager in Rfem 5, but you can enter to your extra account. So that's the news, for example. It's German for my account. Then you can save model templates. The blocks are here. You can see a lot of blocks that are also have got parameters, not all, but a lot. And just use them. And there are also the joint templates for the add-on steel joints. Okay, we can leave the Dlubal Center. Maybe just a hint, when you do, for example, a right click, that's my folder for today, the webinar folder. You can create a new project or new file and so on. So now we leave the Dlubal Center. So, and you can see what it's similar to Rfem 5. Above the menu, on the left side, the navigator data, display, and views, and the tables are here. That's the same as in Rfem 5. So where are already materials, sections, and thicknesses of the last project? I would like to delete all. With a right click on the basic objects, you can delete all basic objects. So, okay. And now all is empty. So we start with the steel frame. I change the work plane to XZ here above, and I view in minus Y direction. So then left above, we start with a new single member, the column. It should be a beam member type, and there are also other member types available as usual. So then section, I create a new section. You have got a large database, as in Rfem 5, it's similar. Or we have a lot of more cross sections in our library. So then, I use European Union and ArcelorMittal and an AGA 160, and I have to create, or I can create a new material also in this dialog. So then region, also European Union, material type steel, carbon steel. You can see a lot of steels, and I use steel as 235 GR. Okay, so we can leave the dialogues and enter the column. It should be 3 meters high. Then I create a support, left above, nodal support. Now a hinged nodal support. I change maybe the settings. No, that's quite good. We have got a gable support. Okay. Okay. So now I copy that column 2 times. I select all, and then with the control key, when I press the control key, you can see a plus. And that means that I will copy that column. So 5 meters and again 5 meters. Okay. And when you press the shift key, you can see a minus. Then you will only move the object. So then you can see the green points, and that's the member representative number 1. And yeah, it contains all the 3 similar columns. And later we will design only 1 member representative. Yeah, and then you will see the advantages. So the horizontal beam is missing, left above, new single member. We use another section. We go in the library. That's a similar workflow as an Rfem 5. That's why I can go a little bit more, a little bit faster through the dialogues. Okay. But when I'm too fast for you, you can use the recording. In the next days, you will get an email with the link to the recording and the model to the PowerPoint slides, and you will get your attendee certificate. So now you can see also here blue points. That's the member representative number 2, and it contains both horizontal beams. Okay, the steel construction is finished, and now we would like to model the concrete slab. We would like to enter it here in that area. So, and you could enter it in the same height as the column height is, with an eccentricity, and use line releases or line hinges. Yeah, that's still possible, but I would like to use a new feature, and that's also very good. That's the rigid link. So I copy that node right above, move, copy selected objects. I create a copy, minus 200 millimeters. Okay. Then I change the work plane above XY, and I set a new grid and work plane origin. So in that point, and you can see that's now my work plane. Okay, I view in Z direction, and now I enter left above the concrete slab. Stiffness type, standard, and I have to create a new thickness. Yeah, the thickness should be 200. Now we can easily calculate. The horizontal beam is 200 high, and the slab or the plate is 200 high. That's why I copied the node 200 millimeters. So we have to create a new material. So European Union, concrete, and I use a concrete C2530. Okay. Okay. So from this point to this point. So, and now the concrete slab is on the same position as it is in real. We can go to the left at the bottom, navigator display. Oh, sorry. So, and then to rendering model, solid model, surfaces and filled including thickness. And you can see it's on the right height. But as we work with axes, we have to, or we need to connect the plate with the horizontal beam. So, and we will use a rigid link. Special objects here in the navigator data. You can see also, for example, the line releases. We will use the rigid link with a right click, new rigid link. We have to select the two lines that we would like to connect. So, and we would like to define a line hinge. We don't want to use a rigid connection, but a hinged connection. So, rotational should be free around the x-axis, and in the x direction it should be also free. So we enter only a small spring that the calculation is running. So okay, that's the first rigid link, and we have to create another rigid link. I can do that also over the menu, insert, special objects, rigid links, and dialog box. And we turn to the same dialog. This line should be connected with the middle line or the axis line of the horizontal beam, and we use the same line hinge. Okay. So then we need to enter a line hinge left above, line support, sorry. It should be hinged. It's okay. So, and now we can calculate the model the first time. So now it calculates, that's good. And you can see in the surface internal forces My, that you can see there is, I move the control panel to the screen, that is a hinged connection. Also here it's clear, and also here. Okay, so then we turn to the next new feature. Imagine we would like to have a glass facade here on this side and on this side, and we don't want to model this facade surfaces, but for this example, you can use the load transfer surface type. And a surface with the load transfer stiffness type has no structural effect. That's really important, and you can use it to consider the loads from surfaces that have not been modeled. For example, as I said, facets, structures, glass surfaces, trapezoidal roof sections, and so on. So let's do that. Left above, we create a new rectangular surface, stiffness type, load transfer. So on this side, on this side, so, and on this side. So we would like, would like to define that the load is distributed in y direction, from the top to the bottom. That's why I select all the surfaces, double click, load transfer, and I go to this dialog, and I define here y stripe. You can also use this function, then it will be distributed in both directions. You can see that in the preview window, but we will use the y stripe. Okay, so then we enter also line supports. Left above, line support, hinges. So here and here. Okay, now the simple model is defined, and we turn to the loads. The self-weight load case is already created automatically. I create a new surface load here above. You have got a lot of load types. That's not so new. That's why I go quickly through this dialog. So, okay, that's only the roof structure. And now we enter the snow load. We can do that with create a new load case, but I will do that over the load wizard. Insert load wizards. You can see the different load wizards. For example, member loads from area load wizards. The import support reactions load wizard, where you can transfer loads from different models, from different model files. That's also a good feature. Then the snow load wizard that we will use now, the wind load wizards, and the moving load wizard. And in Rfem 5 there was an add-on, Rf move surfaces, and this add-on is now included for free directly in Rfem as load wizard. And you don't have to buy such a add-on. So snow load wizard, similar workflow as in Rfem 5. Flat monopitch roof or dual pitch roof, and you have to select the corner nodes. Okay, and you can also define here members or surfaces that will be excluded from the load, similar to Rfem 5. But what's very new and big advantage, you can, or the program has imported all the parameters and the characteristic snow load from the map that we did at the beginning. So then load cases, we should create our one load case is important or need to be created, and we can do that with that button at the bottom, generate load cases. And I will call it snow. Now we turn to the dialog, load cases and combinations. We will turn back to this dialog later. Now we only rename the load case to snow. Okay. So that's all. And now the snow load is created. So the same workflow for the wind. Insert, load wizards, wind load wizards. And the load wizards were in Rfem 5 in the tools menu point, and now here under insert load wizards. So then these load types of walls and roofs are possible. I use vertical walls with flat roof. Base corner nodes. These here 4 nodes. Okay. And the roof corner nodes. So we would like to create a wind only in y direction, or only in plus x direction, in this direction. For this example, I think it's enough. So, and that's wall 4, AD, DA. So, and this wall, where is the building that already exists, and that's our extension. You can also exclude members or surfaces or lines from the load as in Rfem 5. So, and what's also here new in Rfem 6, that the loads or the load parameters are overtaken from the website. So load cases, we need these 2 load cases. We create them with that button. Okay. So that's all. And now the 2 load cases are created. One with roof pressure and one with roof suction. So one load case we have to create now. The construction load, I use the action category imposed loads and call it construction load. Okay, and it should be 1 kilonewton per square meter. Okay, all loads and load cases are created. Now we have to enter the imperfections on the steel columns, and the imperfections are no load cases anymore. They are organized in imperfection cases, and the cases allow you to distribute or describe an imperfection from local imperfections, equivalent loads, initial sway via table, and so on. And what is important, you can combine all of these types, and that's quite new. But the workflow is similar as in Rfem 5. So above, I select new member imperfection. At first, we create the imperfection case, imp plus x. Okay. And now I create a member imperfection. And we use an initial sway, and the definition type should be Eurocode free. Okay. In direction of the strong, also in direction of the strong axis of the cross section. Then the structure height, we can measure it. These are the 3 meters. Okay, and we have 3 columns in one row. And we assign that imperfection to all 3 columns. Okay, and you can display that with that button here above, show imperfection. So now we turn to the dialog, load cases and combinations. I turn to the navigator data, left at the bottom, and I search for load cases and combinations. Do a right click. Okay. So that's what we selected in the base data, the standard and the national annex. But you can change that also here if it is necessary. We use the combination wizard. The result combinations are now only for dynamic calculations. Now we use design situations instead of the result combinations. And for example, you can define a design situation for the design of different materials. The design situations are created. That's the name is similar to the result combinations in Rfem 5, the ultimate limit state design, and now we have got 3 for the serviceability limit state. So let's turn back to the load cases dialog. That where also are our load cases. The wind, for example, 2 wind load cases and the construction load. Then actions, and where's important to mention wind, for example, you can define the action type simultaneously, alternatively, and differently. And it's clear that the wind load cases should act alternatively. So design situations. So let's take a look in that combination wizard. It's the P delta combination static analysis setting, and you can see consider imperfection cases is selected automatically. As in Rfem 5, we have a lot of features. For example, you can reduce the number of generated combinations. You can use user-defined action combinations, favorable permanent actions, and so on. Okay, I can leave the dialog. We select all the 3 serviceability design situations, and for them I use the combination wizard geometrical linear. So, and we use for the characteristic design, or we will activate the concrete design and steel design for the characteristic serviceability limit state design, but not for the frequent or only the concrete design. And we deselect the steel design also for quasi-permanent. So you can see that's very flexible here. So then we can create action combinations. You can see all the load combinations, 52 different load combinations. And when we turn back to the design situation, you can see in the overview what load combinations are assigned for the design situations. Okay. Now we leave dialog. Yeah, and we turn to the steel design. So, and we define the settings for the member representative for the column. We do that only one time for one column. Double click on it. So, and you can see the design types, and we need to create an effective length. And we will define a member length or a buckling length factor 1 for that member representative. We use the second order theory. We assigned imperfections, and that's why the factor 1 is okay. We create a new effective length. Determination type, we consider all for all designs, the flexible buckling design, the torsional buckling, and the lateral torsional buckling. So, and in this dialog, we define the gable support on both ends, and as I already mentioned, we define the effective length factor 1. That's sufficient for the design. So, okay. And I can display all the settings in the navigator display. Left above, I changed to the navigator display. Scroll up, and then types for steel design. I can select the member effective lengths, and you can see the member effective as the buckling factors, the supports, and so on. And you can see all is created for all columns. And when you imagine you have not only 3 columns, but 100 equal columns, you only need to define the settings one time, and that's a big advantage of Rfem 6. So, okay, we don't define any settings for the horizontal beam. We don't want to do a stability design. We say, or we imagine the HEB 200 is supported enough by the concrete slab. And that's why we don't do any, or we create any settings. And then only a cross-section design will be done by the program. And you can see it's no longer necessary to create cases as in Rfem 5. It's much more flexible in Rfem 6. Let's run the calculation or the steel design. Now you can see what we already defined, the design situations, objects to design. Yeah, we leave the settings. I run the calculation. And it's also a new feature in Rfem 6. The calculation is much more faster. Several servers, one per core, are initiated in parallel, each of which calculates load combinations. Yeah, and this ensures a better utilization of the cores and thus faster calculations. You can see this warning message. No effective lengths for the horizontal beam are assigned. And that's why no stability design was performed. And the same for the member representatives. So let's go to the design ratios on members. So, and we select design ratio by sections. Those are the columns, and that's the horizontal beam. And you can see only a section proof was done for the horizontal beam, no stability design. But for the columns, there's a stability design. And when I select one line and do a double click, or I go to this button, design check details, you turn to a dialog with the design check details. And that's a quite new feature in Rfem 6. It was often wished by the customers. The program clearly displays the design check formulas in your design, and including the reference to the used equation from the standard. It's no black box anymore. You can see all the formulas for each design. And you can also send them to the printout report. That all is clear, visible in the documentation. Okay, and also different options, diagram in section, the stresses can be displayed, and so on. So what's also important, section information, the sub-panels, and so on. Okay, so we leave the dialog. I would like to show how you can optimize a cross-section. We will do that only for the column. So we turn to the input data and the sections. And in this dialog or in this table, you can optimize your cross-section. Optimize with a current or in the current row, but you can also define favorites when you define, for example, HEA, HEB, or HEM, and the program should optimize for these three cross-section rows. That's, for example, also possible. So we optimize in the current row, and above we run the steel design again. Only the steel design was done now, and we go directly to the input data and sections, and you can see the maximum design ratio. But the program has done only a new calculation or new design, steel design, but it don't calculate the internal forces. But we have to do that in the second step because we need to consider the different stiffnesses of the system. That's why we run the calculation again. It's now an HEA 100, and we use the optimize section in the model. Okay, and we run the calculation again. And now also the internal forces will be calculated or recalculated. So that should be take only some seconds because of the fast solver. So, and now go directly to the input data and the sections. Yeah, and you can see the updated maximum design ratio. Design ratios members. I can see the stability, bending, and buckling about principal axes. That's the highest design check ratio. Okay, now we turn to the concrete design. I only do a double click on the surface number 1 and I go directly to the design properties. Yeah, they are already selected here. When you don't want to design the slab, then you can uncheck that. Yeah, but we would like to design the concrete slab. That's the concrete cover. XC1 is okay. Dry or permanently wet. You can see that graphic. That's good support. But we will leave the XC1. Concrete design properties, you can define the first direction in X. We'll leave that. Surface reinforcement, we create a new surface reinforcement. We have to define the material. We go quickly to the library. Reinforcing steel, I use B500M. Okay. We would like to use a mesh, not rebars or stirrups. Then a Q mesh. Well, also R meshes. Q mesh 424. Okay, so that's all. You can leave the dialog. And yeah, those are the design configurations. Yeah, we leave the standard settings, but you can change the settings in the case it's necessary. Also, punching is possible directly in the add-on concrete design. You don't need an additional add-on for that, as it was in Rfem 5. So then deflection, we only change the reference length by minimum boundary line. Okay. So now we calculate, or we would like to run the concrete design. So only the load combinations that we don't calculate for the steel design are calculated. Then the concrete design. So design ratio and surfaces. Yeah, there are for sure some singularities. We ignore that in that case. We can also press the button that you don't consider the construction rules. Yeah, this is FEM. But if you want to smooth them, you can do that also in Rfem 6 by using the surface results adjustments. same workflow or similar workflow as in Rfem 5. So let's go to the results. Reinforcement on surfaces, required reinforcement on the top and the bottom. Let's take a look in Z direction. Yeah, and we would like to print that graphic in the printout report. But before I do that, I show you another important feature of Rfem 6. You can see that here, calculate in cloud. For larger models, you can use the cloud. You can outsource the calculation on a computing server in the cloud. There are different servers available, powerful servers. You can clearly arrange the calculations in the extranet. Here, calculation task, my and company. You need to buy credits previously for the cloud calculation. And you have virtually unlimited computing capacity using this cloud technology. You don't use your own solver. You send it only to the cloud, and you can work on your own computer in the meantime. Okay, that's all for the cloud calculation. Yeah, just try it for larger models. It's a very good feature. So then we would like to print that graphic in the printout report. So print graphics to printout report. Because I would like to show you the printout report, we can rotate that, for example, 270 degrees. And we can say window filling here. I've got different options for the display. You can also move the color scale outside the graphic picture. And what's also available is the multi-print. It's similar to Rfem 5, but also possible in Rfem 6. So we can press save and show. I leave all the selections. You can also print parts list of the steel and of the concrete and all other materials. So we press OK. So, and now the printout report will be calculated. So, and what is quite new in Rfem 6, you can work in the printout report and in the program in parallel. That's very easy to handle. You can move the printout report to your second window and work in the program, print more graphics in parallel, and you can see that on the other screen in the printout report. A very good feature. So you can automatically print an overview of the model. Left above, report. You can export to PDF, to HTML. You can translate the program as in Rfem 5. You can insert PDFs, formulas, 3D graphics, plain text, and so on. So now you can see we have got 229 pages, and they were created in a short time. The protocol is much faster, much more modern, and so on. So we leave the protocol open. I turn back to the program. I would like to print formulas in the printout report. Now the design with the highest ratio. So, and I print the formulas in the printout report. Okay. So we can go to the printout report, and we can see at the end of the steel design of the results where are this design with the formulas. Okay, then I would like to show you the last feature. In my eyes, also a very good feature. I go back to Rfem. So imagine we have to modify the horizontal beam because of the glass facet. I go to the section. Imagine we have to cut a bit from the flange here. How to do that easily? With that button, I modify the section in our section. Our section will be opened. So I go to the section left above. I explode it that I can modify it. So, and I move the points here right above in minus y direction 40 millimeters. We cut 40 millimeters and press save and return. And we turn back to Rfem, and the section was updated in a short time. Okay. Okay. So, and now we have to run the calculation again. We need to run the calculation for the concrete design as well. That all is updated. I will do that. So it should take only some seconds. And in the meantime, we can go to the printout report. I wait some seconds until it's finished. So now it's finished. We press that button above, refresh, and we will see when we go to the sections, the updated section is considered in the printout report. And also for the steel design. You can go to the steel design sections. You can see now it's our section, cross section. And all was updated in a short time. Yeah, that's all for today. I hope you could see what's new and what's different in Rfem 6. We have a lot of advantages that you can work faster as in Rfem 5. Just try it on your project, maybe with the trial version. You will see the new program is better, is faster, and yeah, I believe you will love it. I still have an additional hint for you. You can book our online courses. For example, the Rfem 6 masterclass course. It's a course for beginners. It's good for a start in Rfem 6. For more information, you can click on the link at the bottom for the prices and so on. You can also scan the QR codes for the single courses, also for the Eurocode 2 course, reinforced concrete design, or the Eurocode 3 course, steel design. The courses take between 2 and 3 hours. They are divided in several parts. You can stop the course when you want and continue when you have time again. Okay, that should be all for today. I thank you for your attention. Thanks to my colleagues for answering the questions. We will present the second part of the webinar in 1 week. I hope we will see us again. I wish all a nice rest of the day. Bye-bye.